something is increasing or decreasing, you check the derivative. If it's positive, that means f is increasing. If it's negative, that means f is decreasing. This is an if. Very common question is whatever increasing or decreasing at this time. Height is increasing, so let's say we call the variable there for height capital H. If dh dt is greater than 0, or if you wanted to say like h prime is greater than 0, height is increasing. So remember, derivative is slope. So if the slope of something is positive, is that increasing or decreasing? That's increasing, right? That's all this is. So if the derivative is negative, that means you have a negative slope. Negative slope means you're decreasing. So velocity is decreasing if you could do dv dt is less than 0, you could do v prime is less than 0, or you could say a of t is less than 0, because the derivative of velocity is acceleration. So those are all fine. Mr. Brust's IQ, I don't know, let's call it Q, would be increasing if like dq dt was greater than 0, or q prime was greater than 0. And then the smiley face, I don't know, this would be just like d smiley face dt is greater than 0. So this is the main, this is a huge thing. We'll use it a lot. Get used to it. What? Is that point greater than? I was so focused on the smiley face. Happy face dt is less than 0. Smiley face prime? Less than 0. I'll go back to the calculator one because my guess, well, part of it I didn't show you yet, and my guess is something you forgot. Anyways, these two, we got into this a little bit with like the velocity acceleration. If f is population, and we're dealing in years, if f is population, what's the label on the derivative? Population, what? Per year. What? I'm sorry to interrupt your conversation. But then the second one, if they're calling f of x bunnies per year, so they're starting you at the change level. If they're calling f of x bunnies per year, then what's the label on f prime? Or I guess bunnies per year squared. Or population, I call it population, but either way. The per year squared is the part I'm worried about. Yeah. Those two okay? P prime of 15, so estimating slope, there's like 4 different ways you can do this. You only need to know one. Actually, this, well, P prime of 15. 15 is right in the middle. I don't know what the values are at 11, 12, 13, 14, 15. The best I can do to estimate the slope at 15 is to find the slope between the 2 points on either side of it. So it would be like 150 minus 120 over 20 minus 10. So I'm just doing like y2 minus y1 divided by x2 minus x1. And this would be 30 over 10. And if you put the labels with it, so 30 is people, 10 is years, and you know, if you count, so you just leave it like that, but if you wanted to, you could say, okay, that's 3 people per year. Is that okay for now? And then P prime at 20, this is the one where there's actually 4 ways to do it. I'm not going to do them all. You can find the slope between these two, and then 20 is in the middle, so they accept that as a possibility. You can do the slope between these two. I don't love that. I don't know. To me, that's not the greatest, but they accept it. So you just do it like the point next to it. they would accept if you found the slope between these two, or they would accept if you found the slope between those two and the slope between those two and average them together. Any one of those are fine. I think it's easiest because it works every time. Just use the points on like either side. So 200 minus 120 over 30 minus 10. So that would be 80 over 20 or 4. And what's the label there? People per year. So the original is people, and they're asking prime. So we're going. Is that very good? Okay. Grab your calculators. Let me remind you. Let's do that number 3. What code? This is harder than the one that I have trouble with. So you need the calculator. Don't you have 2? Oh yeah. Maybe. Let me show it, and I'll see if I have one. Okay, so we want to take the derivative of whatever that was number 3. Oh, I did it. I was just making sure I remember how to do it. There it is last hour. Let's practice it. So that's what we want. It wants you to take the derivative of 5 to the side of x power, and they want you to plug in 3. So I don't think I've shown you that plug in 3 part yet. So you're going to go F2, no, sorry, F3 for calculus, differentiate, and that's like the ddx part. 5 to the sine of x. So you don't type the y equals. You just like, we're going to take the derivative of 5 to the sine of x. And then I'm going to tell the calculator what variable. So you hit comma, and then you hit x. And you close the parentheses. Don't hit enter. Don't hit enter. Good so far? So if I hit enter, it would tell me the derivative of that. So it'd be like 5 to the sine of x times ln of 5 times cosine of x. It would just do like it's like a gateway problem kind of, right? But I don't really care what the derivative is in this case. I just care what I get when I plug in. So hit the vertical line to the left of the 7. And then just type x equals 3. And it'll tell you, I can't see from here what is the derivative, but I didn't need it. So there's the answer. If you wanted just the derivative, don't put that bar at the end. That's a load of hot mess.
It's giving me how to solve it.
Hit the diamond button.
Wait, seriously?
The green diamond button.
Yeah. What does that mean?
So what did? Hold on.
The diamond button makes it work.
I didn't know that.
This yellow.
Does that takes it from exact to approximate?
Yeah.
Wow. This is new information to me. Very excited. Calm down. I was talking to myself. Alright. So I'm gonna just show what, so if you are in exacts, when you did that problem, you got that, right? So that's like the that's like the gateway, right? 5 sine of x times cosine times ln of whatever. I did not know this, but if you hit diamond enter, it takes it out of exact for you and gives you the decimal. That's really cool. Thanks, Lex. So sometimes it's just already set up in approximate. But this way it could be, if it's set up in exact, because then it gives you like that stuff, then you can go diamond enter. That's cool. Alright, find the derivative of x squared at 3. No. At negative 3. Derivative of x squared at negative 3. Don't do it in your head. That's too easy. You already just got that. Take the derivative of x squared when x equals negative 3. Yeah. You didn't type it in right. You and Noah should get together and try to figure it out. You're a liar. You're a liar. Checking it over before you.
Why would I ever do this in a calculator square? Want me to do this?
Oh, is it supposed to be squared or is it supposed to be cubed? Squared. Oh, it's supposed to be squared.
I have the side of x
That's
at
my
6.
bad.
So I have to open one over there.
Put that in there.
That's not this.
I got -6.
So I just have you practice again, but you're doing the derivative of x squared, so f3 for calculus, differentiate x to the second, comma x. If I stop there, what would the calculator tell me? 2x. But that's too hard for me to do. I can't plug -3 into that, so I'm going to make the calculator do it. And it'll tell me -6. Fair enough? I changed it to -3 to make it even more complex, you know?
Great.
Got me on that one.
Lost?
Yeah, I got 6.
Wow, that's the same numbers they fixed.
That's all I got. I don't want to go on to 4-4 because yesterday was kind of like I think you might be okay at 4-3, but I'm not sure because I wasn't here. Also, are there any questions on 4-2? Shut up, Warren. Are there any questions on 4-2? Because I wasn't here to go over yet. 4 and 4-2. Oh yeah, graph velocity. That's a good one. So you don't have to turn to it. I can just show it up here. Okay, what's up? You should have it done already, though.
I did.
All right. So this is a position graph. So the derivative of this graph, or the slope of this graph, is what? Is velocity. Good. So moving to the right, not moving. Moving to the left, not moving. Moving to the left. So it's positive slope, 0, negative slope, 0, negative slope. But then they say graph the particle's velocity. So again, how do we get velocity from position? We take the derivative, right? Or how do we do it from a graph? How do we take the derivative on a graph? Because we look at the slope. So, because I don't have an equation to like bring down, do the power rule or anything. I just have to take the derivative of this, which means I have to find the slope of this. So the slope of this little segment here, up 2 over 1. So you put a horizontal bar. Actually, the one on the left can be closed. The dot on the right has to be open because can I take the derivative at a quarter? I cannot. So that's got to be open. My next segment, what's the slope of that little segment? 0. So I go down, put a horizontal tick mark kind of at 0. And then I'm going down 4 over 1. So negative 4. And then 0 here because the slope is because we're flat. And then negative 2 in that last part. How does that make sense? Any other ones on 4 and 3? this is a velocity graph. So this is in meters per second. So this is velocity. We're in meters per second. So if this is a velocity graph, it is a velocity graph. Above the axis means positive velocity, means we're moving in which direction? I feel like someone's not here that usually answers a lot of things. Velocity graph above the axis means velocity is positive, means we're moving in which direction? Forward or right, either way. Below the axis, velocity is negative, so we're moving backwards or left. Bless you. So, the particle is going forward, or let's say up here, down in this section, and up in this section. We're above the axis, below the axis, above the axis. So where does the body reverse directions? And x equals 2, and x equals, of course you can't put it at freaking 8. Okay. What'd you say? 7.8? Okay. When is the body moving at a constant speed? So your velocity is constant, it's not changing, which means that it's flat. So that's between 3 and 4. What is the body's maximum speed? So remember, speed is the absolute value of velocity. So one thing you can do is take this graph and just bounce off the axis instead of going through it. And try to recreate the same graph. And now I've graphed speed. So anything that's above stays there, anything that's below flips up to the top. So the maximum speed is 4. I mean, I could have done that here too. I could have said, well, this is the furthest away from the axis, which is -4, but then speed can't be negative, right? So that'd be 4. What are my units here? Meters per second. And then we got speeding up and slowing down. So remember, if the velocity and acceleration are the same sign, we're speeding up. If they're different signs, we're slowing down. Or you can look at like speed. This is the speed graph. When's the speed getting bigger? There, 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 and there. So you list out those parts. 0 to 1, 2 to 3, 4 to 6, and 7.8 to 9. So if you didn't do like the speed graph, the other way you would think about that is like, look at this section. That graph is velocity. So in this region is velocity positive or negative? Positive. Why? Because we're above the axis. Yes. Is the acceleration positive or negative? Positive. Why? Because the slope is positive, which means the derivative is positive, and the derivative of velocity is acceleration. So they're both positive here. That means we're speeding up. We can do the same idea here. Velocity here, positive or negative? It's negative. Why? Below the axis. Acceleration here, positive or negative? It's negative, because that's the slope of this. So since they're both negative, you're speeding up. Does that process make sense? Does that help with that? Does that help with that? Oh yeah, we started at 4.3. Jim and actually from like that. Anything else on 4.2? Okay. So by tomorrow, like when I come in tomorrow, I'm expecting at 4.2 and 4.3 done, and we're ready to start 4.4. So you have the rest of the time. Some of you might be there already. Some of you might not even start. I don't know. But you have the rest of the time to get that done. I'll walk around and answer questions. Nothing to do with what we're doing. it's we haven't